By now, you're probably asking the obvious question. What if we don't have something that you can simply plug in and evaluate? For instance, what if we plug in something and we have 0 in a denominator? Does that mean we have to quit? Does that mean the limit doesn't exist? Does that mean the limit is something crazy? Well, it turns out that plugging in the number into the expression or into the function doesn't always work. Sometimes we can get 0 in the denominator, and sometimes that doesn't give me a problem that I can't overcome. In fact, it rarely does. But in order to overcome that problem, we need to develop a few strategies. So look at this example. We have h of x is equal to this rational function. If I want to find the limit of h of x as x goes to -5, if I tried to plug in -5 into that rational function, I'm going to get that indeterminate form of 0 over 0. So that's going to throw me off. Now, it turns out that there's multiple ways of getting around this, but we're going to look at a couple of ways right now. So we're not going to look at every single method, but we're going to look at the ones that we're going to definitely need in later work dealing with limits. So the first method is to say that if two functions are equal for every single point in some open interval, except maybe at one point. So the way we say this is if these two functions are equal for all points except maybe one, then if the limit of one function as x approaches c is L, then the limit of the other function as x approaches c also has to be L. So if two functions are equal at every point except maybe one, then they have to have the same limit as x approaches that c. Now, this should make sense from what we saw earlier graphically. This is simply saying that, let's say I have a function here written in red, and that function has a hole at one point. Well, if I would to have graphed the function exactly as it is, except I fill in that hole, well, the limit as x approaches that spot is going to be the same whether that hole is filled in or whether that hole is there. So in my case, whether I have the hole or not, the limit as x approaches 2 is going to be 1. So that's the concept. The limit, if we have two functions who are exactly equal except for one point, then the limits of those functions should be the same, even at the point that they may not be equal at. So how does that affect our problem of finding the limit as x goes to 5 of x goes to -5 of my function h of x? Well, we're going to find that limit, and I'll show you what's going on. Sometimes, by the way, people will state that this is finding the limit algebraically. So algebraically, analytically, they can kind of be used interchangeably. So we're going to use some algebra skills in order to find this limit. So the algebra skills that we're going to utilize here are the algebra skills of factoring. So we have our h of x, and it turns out that since h of x is a rational function with a quadratic polynomial on top and a quadratic polynomial on bottom, I can factor the top into a product of two linear pieces. And I can factor the bottom into a product of two linear pieces. Now, the bottom factors into x minus 5 times x plus 5. I'm not going to go over the specific details of factoring. I hope you know how to factor at this stage in your mathematical career. The top we factor, it turns out, into x minus 2 times x plus 5. So notice that we have a common factor of x plus 5 in both the top and the bottom. Now what we're going to do is we're going to create a new function. I will call it k of x. And k of x is going to be x minus 2 times x minus 5. And I want you to notice that k of x is the exact same function of h of x, but with these two factors having been canceled out. That means k of x and h of x are going to be equal except when x is negative 5, because when x is negative 5, k of x is defined, but when x is negative 5, h of x is not. So essentially what we do is we create that. Normally what people do, and this is just to be very blunt, people will take this and write it in the following way. So they'll say limit of x goes to negative 5 of that big fraction is equal to limit of the factored version they'll factor the denominator. And then they'll just write equals limit of x minus 2 over x minus 5. So what usually happens is people will not create a new function and define a new function with a new with a new function name or anything like that. But what they're really doing is they're saying that this function is different from this function at the one point, but since one is essentially a reduced version of the other, they're going to give you the same limits. And so now, once I have this as limit of x minus 2 divided by x minus 5 as x goes to negative 5, now there's no problem with my denominator, and I can just plug in a negative 5 for my x in both places. And it looks like we're going to get a negative 7 over negative 10, which is, 7/10, which is 0.7, however you want to write that. There's a number of ways to write that. And so even though our h of x is undefined at when x is negative 5, we can still find the limit as x goes to -5 by canceling out like terms. Now, I do want to point out that when we typed in -5 into our h of x, we got the 0/0 indeterminate form. So this version where we have a polynomial divided by a polynomial, an indeterminate form of 0/0 often leads me to be able to factor the top, factor the bottom, and cancel out like terms. All right. So that type of indeterminate form is kind of a signal in rational functions that you can do this process. Okay. It's usually you can do this process. It's not a guarantee, but usually you can do this process if we have the 0/0 indeterminate form with a rational function. So what I would like you to do right now is to find the limit of the function r of x given here as x goes to 6. Use the same technique of creating a function, or at least understanding this idea that we can cancel terms and they're equal in all but one spot. So creating a function which is equal in all but one spot, and then utilizing the rules of being able to plug in the x value. So go ahead and do that on your own. And in the next video, I will show you how that is done.